Hello students, in previous lecture we have started the concept that is crystal defects. All of you have studied about that. What is crystal defects, which is also known as imperfections. Then in this chapter we will discussing about the point defects, which is takes place in the crystal lattice of different crystalline substances. Then all of you have studied about that crystal defects, that is point defect, in previous lecture. Then today we are going to study about the different types of point defects. That is, there are generally three types of point defects are there. That is stoichiometry defects, impurity defect, and non-stoichiometry defect. First of all, we will discuss on stoichiometry defects. Then all of you are aware of that there are four types of stoichiometry defects found in the crystalline substances. Then today we will discuss about those types of stoichiometry defects. Then see here, there are generally four types of stoichiometry defects. That is, first, vacancy defect. Vacancy defect. Second one, that is self-interstitial defect. That third one, Schottky defect, and fourth one, Frankel defect. We will discuss about those defects one by one. First of all, see here, vacancy defect. See here, the name itself indicates that vacancy is created in the crystalline substances. Then all of you have studied about that why defects are created in the crystalline substances. Defects are created because of if crystallization process takes place at faster rate. Crystallization if takes place rapidly or at faster rate, then defects are produced. Then during crystallization, the particles of the crystalline substance is missing from its regular site. Then see here, all of you have studied about that crystalline substances in which particles, that means those are atoms or molecules or ions, those are arranged in a regular manner. That means there is a orderness of arrangement of those particles in the crystalline substances. That means see here, the regular arrangement, there is a perfect orderness of arrangement of those particles takes place in crystalline substance. And see here, vacancy means empty space that is created due to the missing of one of the particle from the lattice point of the crystal structure. Then see here, if there is a loss of or missing of particles from its regular site, from its lattice point in the crystal structure, then vacancy is created. Vacancy which is created due to the missing of those particles from their regular site, that is called as vacancy defect. Then see here, when one of the particle is missing from its regular site and vacancy is created at this site, then same type of vacancy is created at another site also, because the ratio of the atoms or ions present in the crystalline substance, it get maintained or it remains same. and therefore that vacancy defect is also developed due to the heating of the crystalline. Vacancy defect is created there. There is an absence of particles takes place in the crystal lattice structure, and therefore here mass of that crystal lattice decreases. Here mass decreases and volume remains same. Volume remains same. Then see here, the mass of that crystalline lattice or crystalline substance decreases due to the absence of particles, and here volume of that or crystal lattice, it remains same. Therefore here as mass decreases, therefore density of that substance decreases. Density decreases because here volume remains same. Then that type of defect is called as vacancy defect. Then you may observe the figure in which the particles, that is atoms, are lost from their regular site, and you may observe that here the vacancy is created at different sites also. That is about the vacancy defect. Then we will discuss about the interstitial defect. That is second one, that is self-interstitial defect. Then see here that self-interstitial defect is also known as self-elemental interstitial defect. First of all, we have to remind that, see here, crystalline substances in which arrangement of the particles is perfect. That means there is an orderness, regularities in the arrangement of those particles. Those particles arranged in the crystal lattice, then there is empty space which you have known about that is which is called as voids, or it is also known as empty space. And that empty space which is created while arranging those particles in the crystalline substance is called as interstitial space. It is called as interstitial space. And see here, in this type of defect, that is self-elemental interstitial defect, the particles from regular site, it shifted from its regular site and it shifted into the interstitial space present in the crystal lattice. That means see here, that particle which is present here, which leaves its regular site and it occupies the interstitial space, and that type of defect is called as self-interstitial defect. This type of defect takes place by two ways. Then in first type, see here, the few extra particles, those occupies the interstitial space of the lattice points in the crystalline substances. See here, those are the extra particles which occupies the interstitial space of the original crystalline substance or crystal lattice. And this type of defect is created due to the mixing of two different materials or impurities if added into the original substance, original crystalline substance. Then see here, extra particles which get occupy the interstitial space, therefore mass of the crystalline substance which increases. Here mass increases, but volume of the crystalline substance, it remains same. And as mass of that crystal lattice increases, therefore density of the substance increases. Density also increases. Then that is the of the type of self-interstitial defect. Then see here, in second type of self-interstitial defect, that is the particles, the regular particles from the crystal lattice, it shifted from its regular site and it occupy the interstitial space. That is, see here, those particles from its regular site, it gets shifted at interstitial space, and therefore here the self-interstitial defect is created. Then see here, in this type of defect, it is a combination of vacancy defect as well as interstitial defect, because vacancy defect is created when atoms or particles, it shifted from its regular site. Therefore, at regular site there is vacancy is created, that is vacancy defect is created, and the particles when shifted at the new position, or which is shifted at the interstitial space, at this position there is a interstitial defect is obtained. Therefore, this type of defect is the combination of vacancy defect as well as it is a interstitial defect. Here, in this type of defect, mass increases, mass of the crystalline substance increases, therefore density of that substance increases. Then we will discuss about the next type of defect, that is Schottky defect and Frankel defect. Then we will discuss about the next type of defect, that is Schottky defect. Schottky defect. Then see here, Schottky defect, this type of defect is created in the ionic solids or ionic compounds. Then here, equal number of cations and anions are missing from its regular site, and which creates the vacancy at the site of cation and anion, from which they are lost from its regular site. Then here the vacancy is created due to the loss of equal number of cations and anions. Therefore here ratio of cation and anion which remains same, and therefore there are two holes are created per pair of ions, and that defect is called as Schottky defect. Such those type of paired cation and anion vacancy defect is called as Schottky defect. Then see here, that type of defect is obtained in the compounds like NaCl, AgBr and KCl like compounds. Those type of defects are produced, that is Schottky defect is produced in those compounds. Then what is the condition for creating that Schottky defect? Then see here, Schottky defect is obtained in those ionic compound which having the high degree of ionic character. That means that NaCl or KCl which having the high degree of ionic character. Therefore, in those compounds, Schottky defects are produced. That means this defect produced in ionic compound, which having high ionic character, as well as, see here, this type of defect is produced in those ionic compound which having high coordination number of ions in the crystalline substance, as well as if there is a small difference in the size of cation and anion. Then third condition, if there is small difference in size of cation and anion, then that means ratio of cation and anion, it is nearly equals to 1. That means it is nearly equals to 1 because the difference in the size of cation and anion is very less. That means those size of cation and anions are nearly equal, and therefore that ratio of ionic size of cation is to anion, that is nearly equals to 1. Then in those type of compounds, Schottky defect is observed. Then see here in NaCl, see here NaCl, Na plus ion is there and Cl minus ion is there. Then see here Na sodium, which is present in third period, as well as Cl is also present in third period in the periodic table. Therefore, the size of the cation and that anion remains nearly the same. Therefore, here the Schottky defect is observed in those type of ionic compounds. Then see here, there are few consequences are there. That is, we will discussing on consequences of this defect. Then first of all, see here in this type of defect, in Schottky defect, then see here same equal number of cation and anions are missing, and therefore here mass of crystalline substance, crystal solid, it decreases and volume remains same. Volume of crystalline substance, it remains same. Therefore here density of crystalline solid, it decreases. That is the Schottky defect. That is the one of the consequences of Schottky defect. Then second one consequence, that is, see here in this type of defect equal number of cation and anion are missing. Therefore here the electrical conductivity remains same. That means in ionic compound there are presence of equal number of cation and anions are there, then it is electrically neutral. Then here in Schottky defect equal number of cation and anions are missing. Therefore here electrical conductivity, electrical neutrality is maintained. That means that ionic compound with Schottky defect is also electrically neutral. Then that is about the Schottky defect. Then we will discuss about the Frankel defect, that is the Frankel defect is one of the stoichiometric defect. Then we will discuss about the last defect of the type of stoichiometric defect, that is Frankel defect. Frankel defect. Then see here, in this type of defect, then this type of defect is also produced in or observed in ionic crystalline substances. Then see here, for example, AgCl, AgBr, silver bromide, silver chloride, silver iodide, or calcium fluoride, like those compounds. That type of defect, that is Frankel defect, is observed in those type of crystalline substances or ionic compounds. Then what is Frankel defect? Frankel defect, it is produced, it is due to the shifting of cation or anion, shifting of ion from its regular site, and it occupies the new space, new position, that is in the interstitial space of the crystal lattice. And here all of you are aware of that generally cations are smaller than anions. Therefore, here cations present in the crystalline substances. See here in the figure, it is an ionic compound in which Frankel defect is obtained. Here cations are generally smaller than anions. Therefore, here cations which leaves the regular site and which occupies the interstitial space of anions, and therefore here vacancy defect is created at the regular site of cation, and the interstitial defect is also created where the cations which occupies the interstitial space. That means this defect is a combination of vacancy defect as well as interstitial defect. Then see here, there is the condition of that defect, conditions for arising those type of defect, that is here this type of defect is observed in ionic compound which having low coordination number, and as well as this type of Frankel defect is obtained in which there is a large difference in the size of cation and anion. Then that type of defect which is found in those compounds, that is silver chloride, silver bromide, silver iodide, calcium fluoride, like those compounds, Frankel defect is observed in those type of compounds. Then we will discuss about consequences of this defect of Frankel defect. That is, first one, see here, as here no any loss of cation or anion from it, therefore mass of the crystalline substance, mass of the ionic compound which remains same, it does not decreases or increases, and volume of the crystalline lattice, it remains same, volume of the crystalline substance or ionic solid, it is also same, therefore density of that substance, it remains same. That means the density does not changes. as well as here no any loss of anion or cation. Therefore, here equal number of cations and anions are there. The second consequence is that is here equal number of cation and anions are there. Therefore, they are also electrically neutral in nature. That means here electrical neutrality is also maintained here. Then that is about the 4 different types of stoichiometry defects. Then you will solve the examples from exercise which is related with those defect or those concept. In next lecture we will discuss about the impurity defect and their types. Thank you.